Here in Lecture 7, we're going to take a look at a couple of efficiency and convenience facilities of C++, namely inline functions and default parameter values. If you define a member function, that is, provide a body of code for the member function right in the class definition, then that function is implicitly what's called an inline function. And what that means is that the compiler may optimize away the actual function call overhead normally associated with calling a function. For example, here on slide 3, we have an example that we've already seen. We have our employee class here with its constructor. In the private section, it has rate, which is a double, as a data member, keeping track of the hourly rate of the employee. In the public section, we have this member function, getRate. GetRate is a const member function. That means that it doesn't in any way change the employee object that it's been called on. It returns a double. And specifically what it does is to return the value of the rate data member of the current employee object. So in main, shown here on slide 4, we have declared Alex as an employee object with a rate initially of 57.25, and in the cout statement we're calling alex.getRate to obtain the rate of Alex. Now to us, the developers of the main function, this is a function call. We're calling the member function getRate on the current object Alex. But when the compiler compiles this code, the compiler may simply notice that the definition of the function is so simple, it's simply a return statement of the rate data member's value. The compiler may avoid the function call overhead and simply give you the value of alex.rate. Now, this may seem like an access violation because rate is private within the employee class, but remember that it's the compiler that is enforcing the private access control, and in the code that the compiler generates, the compiler is free to break those rules itself if it can optimize some code without changing the meaning of the code. Okay, so simply by obtaining the value of the rate data member of the Alex object, the compiler is able to make this a bit faster than setting up the overhead of actually calling the function and then returning from the function. Now, if the class that you're defining is long, that is, it has lots of member functions and perhaps lots of data members and some types being defined and so on, then even if you have short 1 or 2 statement function definitions, those can really clutter up the class when some developer is trying to read your class definition to figure out what member functions are available. So what's often done to maintain the efficiency of inlining but reduce the clutter within the class definition itself is to move the function definitions below the definition of the class and then explicitly declare these functions inline using the inline keyword. Okay, and that tells the compiler to do what's possible to avoid function call overhead when these functions are made use of in an application or in some other code. Now, it's important to understand that inline is simply a request to the compiler. Inline will not force the compiler to do a full inline replacement of a function call with the body of code of the function. If the function is long and complicated or recursive or is simply too difficult for the compiler to figure out how to expand in line, the compiler will instead implement the function as static, that is, as a file local function which eliminates the problem you would otherwise have from having this function defined multiple times in multiple files. But then you will still have the function call overhead when you call such a function. Alright, so here on slide 6 we show the employee class with its public member functions declared and its private data members declared, but we have moved all of the inline definitions, even of the very simplest functions, below the definition of the class, still in the header file, but we have declared them explicitly inline so that we get the benefit of the efficiency that the compiler can provide, but we don't have clutter in the definition of the employee class itself on slide 6. Alright, so the definition of the employee class on slide 6 is very clean, and below that class in the header we are able to define all these simple member functions as explicitly inline. One little picky detail to notice here is that nextID is a static data member. getNextID is a static member function that simply returns the value of the nextID static data member. Here on slide 7 we are defining that getNextID static member function as inline. However, it's an error for some reason to define the function as static in the inline definition. Okay, so you do declare the static member function as static in the class definition, but for whatever reason you don't define the function as static below the class definition. This is just one of those picky details that C++ likes to throw at you. Here on slide 8, notice this is the code file employee.cpp, in which we would normally have a bunch of definitions of member functions. But in our case, the member functions that we've defined are so simple that we've defined all of them as inline within the header. So the only thing that's required in the code file is we do have to include the header, and we have to define and initialize the nextID static data member. So it's reasonable to ask, well, why don't we just define every function inline all the time and take whatever the compiler is able to give us as far as efficiency? One problem with this approach is, suppose that you have proprietary logic going on in some of the definitions of your member functions. If you define functions inline, whether implicitly inside the class definition or explicitly by using the inline keyword below the class definition but still in the header, you're going to be revealing all of these implementation details to anybody who uses your class, because people cannot use your class without being able to include the header, and the header is a human readable file that they can just look at. So in part, the decision as to whether to use inline functions or not is a decision about how much you're willing to reveal about implementation details of your class.